Welcome back to my ModernGX tutorial, another video. Last video, well, we have drawn that epilepsy warning, changing color. And yeah, this was quite nice, and we would be kind of like the point where say, let's go into texturing. But recently a YouTuber has uploaded a video on how to draw circles, which was totally fine, but it had some major drawback. Well, I thought, hey, wait a minute, why is he hard coding that value? I don't want to blame him. He does amazing videos, and I don't want to do there anything. It's amazing. He just like omitted this for, I think, simplicity, and because it was not done like in a proper API. It was done just on as a demonstration purpose on the website called Shader Toy, and for that purpose, when you kind of like have that fixed resolution and everything, this was totally fine how he did that. But I'm gonna actually show you why this is not good. So yeah, we are gonna draw a circle today. First of all, let's get started by... I'm not gonna go into the details, so I'm gonna link the video from this YouTuber in the video description if you are interested in the basics of how to draw a circle. I'm not gonna cover this again here. I'm just gonna go step to that, and I'm just gonna rush through that. So first of all, we need to exchange some data between the vertex and the pixel shader. For that, I'm gonna create a struct here, which is our, just gonna call this vertex data here. And inside that struct, we're gonna have a float 4, which is the position, which is the SV position. We're gonna have a float 2, which is the UV, which is our text coords. Or just text coord for texture coordinate. And I'm gonna use this as a input to the vertex shader. So I'm gonna have an input here, which is the PXD, pixel data. And inside of the vertex shader, I'm gonna return that one, which is the VXD for vertex data. The position will just be as simple as we had it previously, just like that call. The texture coordinates will be equal to the position, and we're just gonna return that VXD. We also need to remove that SV position here, and this should at least make the shader compile or show us exactly the same thing. Now what we want to do is we want to go into that pixel shader again, and we want to actually tinker around with that last value. So first of all, I'm gonna create a float distance. This is the distance from the current point to the center of our circle, which will be in the center of the screen. And since our quad has the dimensions 2 by 2, means that we have a maximum radius of 1. So yeah, just that you know the dimensions. And I need the length, from the UV coordinates, so pixel data UV. And I'm just gonna input that as the alpha value. Or maybe not, let's not do this as an alpha value for now. Let's actually use this here just as a multiplier to the color value. And what you get is something like that. Where basically the center of everything is black. And then we kind of like get out of that until we are at the proper like color values. We kind of like have this is like all gray, only like the spots and the edges are a bit light. Now what we need to do is we need to actually take the inverse of that, which is looking something like that. And now we need to put this into the step function. The step function basically will go 1 as soon as this value is kind of like reached. As soon as we get 0, we get 1. And if we make this like that, you can see that we have a full screen circle here. Now, it's kind of like stretched and not rounded. Also, we need to do some aspect ratio correction. And yeah, I'm gonna do this by introducing a new root constant here, not in this file. For that root constant, I am going into my root thing here. I'm going to duplicate that one. I'm going to introduce another root constant, which will be our aspect ratio. Let me also document this, which is a one size root constant, which is the aspect ratio. And let's also put this at a different slot. Maybe let me also document these slots here as well. B0 and B1, which is the aspect ratio. Now let's go into the vertex shader, because aspect ratio will be taken into account in the vertex shader. And for that aspect ratio, we're just gonna say const float aspect ratio register B1. And now I'm gonna take this aspect ratio, and this is gonna be multiplied at the x of that position. And if I would start this now, I have errors. Why do I have errors? Vertex data is not known. Wait a minute. Alright, I forgot this trailing slash here. Now we should be good, and we see nothing, of course, because we don't have this value yet. The aspect ratio will be computed in my win main. It will be computed after the window has been created. The window doesn't have an aspect ratio function for now, so I'm just gonna hardcode this to window get height divided by window get width. But of course we need to cast this to a float first, and if you don't do this we just get 0. So there we have our aspect ratio, and of course the aspect ratio needs re-evaluating after the window has been recessed, so we're going to copy this over here as well. Now we're going to go into our root configuration. Where is it? It is here, but the aspect ratio is not in existence here. Good. So this is amazing. Let me grab this here and just introduce it up here. Why did I have an N there? I'm not quite sure. So let me double this here, add a comma here, increase the count to 2. There's just 1 now, and this is going to be a pointer to my aspect ratio. Let's start and see what's doing. And you're going to see nothing. And this is the point where your mind is going to blow, you're going to debug hours, and you then finally decide that DirectX 12 is an asshole and you'll quit. For real, I had this issue when I learned DirectX 12, where I used the second root constant, and it looked all good, but it didn't work. I'm gonna show you why that is. Let's go into Inside Graphics. Let's launch this. And let's take a frame capture. And let's take a look at the frame capture here. And take a look at the frame debugger and the root parameters. And first of all, you need to just select the draw. And then I'm going to take a look at the root parameter. So you're going to see that you have 2 root parameters specified here. Let me just close this up. This is the first one. It's that color here that is properly set to 0, 0.500. And the second one is that one here, the aspect ratio. And you can actually see that this aspect ratio is colored red. It's not seeing that there's no value. Now you would wonder, why is there value? If I take a look at this, actually, you can see that the function was actually called with the proper arguments, and you might wonder why there is nothing. And this has something to do with memory alignment. So as you can see, the GPU uses 32-bit values, and most of the time you have 4 components, RGBA or XYZW. So the GPU is aligned to 128 bits. Or 4 floats, float 4. And float 4 means 16 bytes. So as soon as you are using a new root constant and use this in a shader, the GPU expects this new value to be aligned to that 128-bit boundary, which would be an offset of 16. But if we take a look at what we have defined in our root signature, you can see we have 3 values and then 1 value. So this is actually not aligned at 16 bytes. This is aligned at 12 bytes. And well, we need to fix it. How do we fix that? Put a 4 on there. Go back to debug and maybe kill that. And if I would start this now, still nothing. Well, it was not working. Why was it not working? It was a bit different now. Actually, it doesn't like that 1 here as well. So I'm not quite sure why, but just make these always as 4. Even if you don't use 4, just make them always 4. My advice of the day, make this always 4. And of course, And of course make this 1, of course. But it's just documentation. Make this always 4. I'm not quite sure why DirectX is such a bitch in sometimes like that, but if you make this properly, you can see, well, we have aspect ratio correction now. Good job. Alright, but I don't want to already have aspect ratio correction, because if I just have aspect ratio correction, I cannot show you what the issue actually is. So, let's do this. We want to actually get this somewhere. We want to make some scaling. And now I'm going to abuse my color key to also get another floating point value, which is our scaling, which is going to start at 0.2 float. You're going to see that why I'm going to start at 0.2 float in a while, but for now just take it for granted. And let's actually refactor that. If that, then that, because now we're gonna use some more key codes. I know this is getting dirty, but hey, that's how it is. So add another else if here, so I'm gonna check for V key up. So if I press the up key, I'm gonna set my scaling to STD. How we're gonna do up key is plus. So we're gonna do a minimum of 1.0 or scaling plus 0.01 float. No, like that. So basically I just want to increase that scaling factor. And if I am, oh yeah, I'm an idiot. Of course this will be, yeah, this will be always at key up. Good with that. So we're gonna also have a V key down. And actually, if I'm going to do this like that, I actually want to increase this by 1 every time. But in this case, I want to go down. Such I have a maximum value to scale it down or scale it up. And this should influence the scaling value. Now we need to plug in the scaling value as another root constant. And we're going to do this again. I know that this is not how you would do that, but it's just to get the job done fast. We're gonna have the scaling here, so we introduce the scaling here as well. It's just the scaling here. Let's double this, buffer 2 for root constant. This is all scaling. Maybe we should now properly specify this here, so we have 3 components, 1 component, even so we have always 4 here. So now at B2 we have our scaling, so let's go over here and add the scaling here and just multiply the scaling in, and boom, we should be good and have some scaling. Yeah, because I always forget this guy. We should have this circle scaled, and now when I press the key it's kind of like resizing in steps. Okay, maybe I shouldn't, maybe let's tweak this a bit. I don't like how this is scaling. Let's do 0.25, and let's make a minimum of 0.05, and maximum will be still 1. And this should give us a bit of nicer scalings here. Of course I need to kind of like spam the keyboard, which is good because my audio is not working properly. But it's working like that very nicely. Alright, I just changed a few of the scaling parameters that makes it a bit finer in scaling. But, well, yeah. Let's actually now address the biggest issue that we have in this on this circle. Basically, I mean, this is still working if you care. Like, yeah, the biggest issue that we have is that the edge is aliased. We need to do some anti-aliasing, and well, you probably have watched the other video first. So anti-aliasing, very easy, smooth step. And this requires another parameter, so let's do that one. And let's see, it's a bit smoother. Maybe we're gonna do like that, make this nice and smooth, and yeah, it's looking kind of good. It's getting where we want. Maybe make it a bit better, a bit more smooth. Oh yeah, that's what I want. This is a nice smooth circle. Well, now it's too smooth. I've scaled it up and it is looking ugly. Why is that? Well, because we have an issue there. This hard-coded value here, the 0.2 float, is hard-coded. This is just for one resolution. We need to get something that is resolution dependent. So depending on some resolution. And for that, there's actually a function that can do this. It's called DDX or DDY. It doesn't depend what we are doing. It's a quad that we are drawing, so it doesn't depend if we are taking the X or the Y, and this is like a partial derivative to X of that given parameter. In our case, which will be the PDX, UV, and accordingly now the X. I could also use Y and Y here. But basically pixel data, UV coordinates X, and basically what this is kind of like that changing rate of that parameter on the per pixel base. So basically if the triangle is small, the changing rate is higher, and if the if the quad is small, the changing rate is higher, and if it is if the quad is bigger, then the changing rate is lower. So just adding this should give us already an improvement. It's not quite good. You can still see some aliasing here, so I probably need to modify this. Maybe let's make this at 0.2 float, and this is looking quite promising. Now you can see that we have maybe it's a bit too staircasey still. Maybe let's do this at 0.5 floating points. I still hard-code a value, you see, but basically this value stays hard-coded for every resolution because it's been scaled by a resolution dependent value, and this just makes it quite more flexible. And I think we are now at a value that is acceptable. Yeah, I think so. I've played a bit around with the value, and I've ended up at 2.8, which at least for me is looking promising. I mean, you could still treat this and also kind of like try different algorithms here, but for me this is actually looking good. And then I think now even the small circle gets anti-aliased. It's, yeah, kind of like you can still see the pixels because the values are not 100% correct, but it's actually quite good. I'm actually quite happy with that. Maybe it's just my eyes that if you stare at the circle too long, you get dizzy. No, but yeah, basically this is how I want that. It's now resolution independent of that circle. It's now scaling with DDX, and yeah, this is basically just some circle that we have drawn. Alright, so that's it for that video. In the next video I wanna make this circle textured. So stay tuned. I'm gonna commit this because I forgot this last two videos and I need to group them, but yeah. Thank you for watching. We're gonna see us in the next, and then actually the last ModernGX tutorial. So yeah, thank you for watching. See you in the next video. Have a nice day. Make sure to like and subscribe, and yeah, bye.